Okay. Um, we will start the lecture soon. Okay. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Good morning, everyone. Distinguished our speaker, Associate Professor Fazida Muhammad from Faculty of Industrial Management, University Malaysia Pahang Al Sultan Abdullah, PSA. Distinguished the head of the Institute of Research and Community Service, who also heads of the Institute Partnership of Telkom University Purwokerto, Dr. Atrik Febriani. Distinguished our head of Bachelor Degree of Logistic Engineering Study Program, Telkom University Purwokerto, Mrs. Nabila Nurkistani, STMT, and our lecturer, students, and also the attendee of the special lecture. It's a great honor and pleasure to welcome you to today's international guest lecture organized by the Logistic Engineering Study Program, Telkom University Purwokerto. In a world where complexity is the norm, whether in business, policy, defense, or technology, the ability to simulate before we commit has become one of the most valuable strategic capabilities an organization or individual can have. Today's section, we will explore about the strategic simulation, the architecture of choice from simulating system to engineering decision by Associate Professor Fazida Muhammad, who has 20 years of teaching experience in business management as well as logistic and supply chain management. Many of you have already learned simulation software such as AnyLogic, FlexSim, PowerSim, Arena, and etc. This lecture will take us to learn how to know which a question is worth modeling, how to translate the uncertainty into scenarios, how to rate models output as a decision and not just a number. And then across the session, you will be taken through some real case studies. This lecture will be guided into the lecture and discussion section. So for the participant and for the attendee, please present the good manner by muting the microphone during the session, and also open the camera and use the background. The participant will allow to give a question by mentioning on the comment section or raise your hand on the question and answer section. And don't forget to fill the presence form that you can see on the comment section to get the certificate of this lecture. So ladies and gentlemen, please stand for the National Anthem Indonesia Raya and followed by Telkom University Mars. Oh, okay, wait. Azril, can you share screen?
Satukan tekad bersama, padukan langkah, bawa bangsa menuju garis depan. Raih cita rajut asa, singkirkan lengan, tingkatkan inovasi, unggulan berprestasi. Semua demi keluhuran bangsa, masyarakat adil mampu sejahtera. Laksanakan pendidikan dengan semangat pengabdian, ciptakan kehidupan gemilang. Telkom University, kebanggaan Pertiwi, maju dengan karya, berperan bagi bangsa, bagi Indonesia, bagi dunia. Telkom University, sinergi bangun negeri, maju dalam ilmu pengetahuan. Satukan tekad bersama, padukan langkah, bawa bangsa menuju garis depan. Raih cita rajut asa, singkirkan lengan, tingkatkan inovasi, unggulan berprestasi. Semua demi keluhuran bangsa, masyarakat adil makmur sejahtera. Laksanakan pendidikan dengan semangat pengabdian, ciptakan kehidupan gemilang. Telkom University, kebanggaan Pertiwi, maju dengan karya, berperan bagi bangsa, bagi Indonesia, bagi dunia.
Okay. To officially open this lecture, we would like to invite the head of the Institute of Research and Community Service, who also heads of the institution partnership of Telkom University Purwokerto, to delivering remarks to Dr. Atik Febriani. I am delivered.
Okay, thank you, Ms. Ratih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Good morning, everyone. Welcome to Dr. Fazida binti Muhammad from University Malaysia Pahang Al Sultan Abdullah. Nice to meet you here. And Ms. Nabila as Head of Logistic Engineering Study Program, and our moderator, Ms. Ratih Windu Arini, and all student and participant joining us today. Thank you for being part of this international guest lecture organized by Logistic Engineering, Telkom University Purwokerto. Today, we are very happy to learn together about strategic simulation, the architecture of choice. This topic is very relevant. As we know, decision making is very complex. Through simulation, we can explore different scenarios, understand possible impact, and we hopefully make better decision. We are honored to have Dr. Fasida with us today. Dr. Fasida has strong experience in logistic and supply chain management, simulation, and also operation management, which make her sharing very valuable for us today. I hope everyone can enjoy the session, gaining new insight, and join the discussion actively. Thank you, and let us begin the session. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Dr. Atik Febriani. And then we also would like to invite our head of Bachelor Degree of Logistic Engineering Study Program, Telkom University Purwokerto, Mrs. Nabila Nurkistani, STMT, that has joined the lecture with us. And for Mrs. Nabila, the time will be yours.
Oke, thank you, Miss Ratih Windu Arini. Assalamualaikum warahmatullahi wabarakatuh. and good morning and a very warm welcome to everyone here. Distinguished guest speaker, Dr. Fazida binti Muhammad. Nice to meet you, uh, Dr. Fazida. And then respected faculty member, Dr. Ati Febriani, students, college, and participants from various institutions. It is a pleasure to welcome all of you to our international guest lecture organized by the Logistic Engineering Study Program, Telkom University, Purwokerto. Today, we are honored to have Dr. Fajida binti Muhammad from University Malaysia, Pahang Al Sultan Abdullah as our guest speaker. Thank you, Dr. Fajida, for joining us and sharing your knowledge and experience with us. To all students and participants, I encourage you to enjoy the session, stay curious, and actively participated in this discussion. Thank you for being here, and I hope you have a great learning experience today. Now, without further delay, let's begin our session. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you, Bu Nabila, for the deliver. And then before we start our lecture, I think we can take a picture first, and then we can focus on the lecture. To Mr. Azril, you can guide us to take the picture.
Okay, wait, ma'am. Start by 3, 2, 1. Okay, and again. 3, 2, 1. Okay, it finished, ma'am.
Okay, thank you, Azril, for the taking picture. And then we will continue the lecture. Okay, allow me again, on behalf of Logistic Engineering Study Program, welcome to today's international guest lecture. My name is Ratiwindu Arini, and also a Logistic Engineering Study Program lecturer who will be moderating as an MC today's session. And then we will once again welcoming our beloved speaker, Associate Professor Fazida Muhammad from Faculty Industrial Management, University Malaysia Pahang Al Sultan Abdullah. Mrs. Fazida has experienced 20 years of teaching, as I said, including some courses about supply chain and logistic management, international transport logistic, warehouse and inventory planning, and industrial logistic. She also interested in system dynamics, discrete event simulation, data envelopment analysis, operation management, supply chain management, and logistic management as a research interest. And then she currently granted a research award from University Malaysia Pahang Al Sultan Abdullah about flood sense data-driven flood management dashboard for decision support gold medal. For decision support in the gold medal creation, innovation, technology, and research exposition, and also another granted of research and the other granted from the other organization or institution also in the last few years. And then for Mrs. Fajida, how are you today? Even though we have already chit chat before before the lecture start.
Alhamdulillah, I'm doing great in here, hoping the same at your end. Thank you so much for having me today.
Okay. I hope the participant also enjoy the lecture section. So to Mrs. Fazida, the time will be yours to give us a lecture. It's expected about no more than 1 hour, and then we follow with a question and answer section.
Okay, thank you. Thank you so
Thank
much,
you.
Ms. Rati. A very good morning. Okay, Assalamualaikum everyone, especially to the management, okay, of the university and the program itself, Dr. Atik, we have Ms. Nabila, and of course, the important person today, the moderator. I'm always in communication with Ms. Rati, yes. I think from the very beginning, she approached and until today. Thank you so much for the invitation. And I would prefer to say this session is more on a sharing instead of lecture, okay, because I'm going to share what I have been doing with my students so far, and probably also listen to the students' view later on, or the lecture itself. Okay, I will share my screen. And by the way, thank you for a brief introduction about me. So probably I just add a bit related to that. My bachelor degree starting from the business management per se. And when I first involved using this modeling and simulation, and it was actually quite challenging. Yeah, it's quite challenging for me to learn all this thing. But then it's very interesting because it again reflect on the decision making. We provide evidence. Okay, we provide the numbers, the calculative numbers, and provide evidence. And of course, we are academician. We are not a consultant. Okay, so we provide them with options. Okay, the industry with options. So that is where the decision comes later on once they have, we provide options with all the different scenarios, and then they will opt for that. I always told this to my student. Yeah, I tell this to my student that you are not a consultant. You cannot force people to follow what you suggest. All right, but you are an academician. You provide based on the theoretical and provide based on the experimentation and give them uh, options. All right, so that's the thing that I always tell my student basically. Unless you are being appointed as consultation, that will be a different story. So let me share my screen. Okay, just give me a moment. Yeah, can everyone see my screen now? The slides?
Yeah, we can see your screen clearly.
Okay, that's good. Alhamdulillah. So before we begin, I just want to probably just tell everyone that if you have any question, probably you can just drop in the chat bubble. Okay, and then we'll go one by one after that. Okay, so again, good morning. So this session, like what Ms. Rati just mentioned, will run about 1 hour. I will definitely go through all the slides, and I'd love this session to be interactive. And we have a dedicated discussion session near the end, yeah, Ms. Rati? Okay, so put on hold on the question along the sharing session. So I believe that many of you here have learned the simulation tools. You have learned the AnyLogic, the power sim, the flex sim, probably some familiar with arena simulation. Okay, in University of Malaysia Pahang specifically, we expose the students with arena simulation using the training version, and some of our postgraduate students using advancing, okay, and arena, and also the I think and the ISEE related to the system dynamics. So again, like what I said, I am not here to teach you how to build a simulation because many of you are so familiar with that. But I'm here to talk about something most of the courses skip. How to think with one. Okay, means to say that um, this specific subject of this session, it should be properly understood. It's not about the software. It is about the architecture behind every decision. And every single decision maker needs to make, okay, under certain uncertainty. And I really hope by the end of this hour, probably you might see that your AnyLogic or other software that you have used, you might see it differently. It is not as a tool, or not just as a tool to operate, but also for a discipline that you might practice. So you have to remember one thing, because most of you are engineers, I believe. You're going to be an engineer later on. You're taking this industrial engineering program. So in engineering, we can say that mistakes have consequences. Okay, so you need to properly plan, because a poorly planned in production line, for example, it costs money. Okay, a wrong inventory policy costs or give impact to customer's order. And any bad evacuation, especially during the pandemics or epidemics, actually will cost lives. Okay, so in simulation, it's a different one. You can make, I can say, mistakes, because it's simulation. It won't touch a real operation. It won't touch a real human lives. It touch the model in your computer, and you can learn it before you even touch the real world. You can test it. Okay, so let us move to the next one. So yeah, like what Ms. Rati has explained, a little bit about where I'm speaking from, briefly. Okay, I promise you that this is not a slide about me per se. Just want to give just a brief introduction again, that I have involved with several research still ongoing, inshallah. Okay, related to the one that being stated in here. Okay, and up to this one. So my focus will be on the logistic and supply chain. So you can see in the next few slides, sorry, that my sharing will be focusing on examples of the port simulation, the warehouse, so on and so forth. Okay. Now let us move to this one. Okay, this is a very interesting one. So let me start with a story, okay, instead of a definition. So it is 11:47 p.m. Probably in Indonesia at a particular time is 10:47 p.m. Okay, so in a food and beverage company, a warehouse in Shah Alam, Malaysia, you know, tomorrow probably is the biggest promotional sale of the year. And as you may know, even in Malaysia, I believe the same probably being practiced in Indonesia. We have e-commerce platform with several dates of promotion. For example, 66, 77, 88, 99, or probably the payday sale. So in this case, tomorrow is the biggest promotional sale of the year from several e-commerce platform. And right, we can say that the order volume is increasing, because is about to search, because you know, when you have provided a sale, means to say there is a markdown, there is some promotional, so the orders volume might be multiple in a single day. As a manager, you might standing on the floor looking at your picking line, looking at your packing station, looking at your current inventory, or even looking at your loading bay. So as a manager, just imagine yourself as a manager. You might have a question, will there be any hiccups tomorrow during picking, packing, and loading, right? But will there be also any issues, problems occur in between? So, you know, these are the types of questions that might pop up in the manager's mind at a particular time. But of course, because he or she or you or me, we cannot simply say that A will be, you know, there will be a certain problem at A station or B station. We might, based on our intuition, based on our past experience, okay, we just based on that. However, in a modeling and simulation, we can test. Remember, we model and we can test it. All right. So it is very uncomfortable if you do not know which station probably might face issues in most companies and most difficult nights. So they make a guess, they based on their gut feeling, based on what happened last year. So it is expensive actually. Yeah, it might occur and affect the cost. So this is the exact situation that brought me and one of my undergraduate students. Okay, we have worked together with this one e-commerce platform and one F&B companies, okay, to see and to do exactly what my student is Amar, he's been trained to do, build a model. But notice what I'm not saying. I am not saying we open the FlexSim. I am not saying we open arena simulation. I am not saying that. I am saying we ask a strategic question first. And that is where the software came second after that. Means to say that we have to understand what the problem is. Then only we know what kind of software or what kind of simulation tool that can be used. All right. So I'll just stop here a bit. I will continue about this particular case later on, yeah, right away after this, right? So let us go to the next one. So this is the core distinction I want to draw attention from everyone before we can go any further, because everything else today, okay, builds basically on these specific things. Okay, you have a look at the left side here. This is what you have been taught, the syntax of any logic, the flow using the FlexSim, the stock and diagrams using PowerSim. In here we use I think. So these are real, valuable technical skills. And okay, and you guys, you need to be so proud because you have already learned this. And it took effort in learning all these specific software. But notice something about everything on that left side. It is all about how to build a model. It is about how the model should be looked. None of it tells whether to build it, what to model, or what to do once the model gives you the answer. So this is where the right side all about. Okay, which is the actual G's of a strategic simulation, knowing which question is worth the cost and time of modeling. You will translate uncertainty into scenarios because you are going to play and test the what if simulation. What if the demand multiple? What if the machine breakdown? Okay, what if? So the what if scenario will become a structure in a computer that you can test it. And when you read a simulation output, it will not just mean a number. It is a basis for a decision making or someone that going to defend in a boardroom, because you need to present it. Every decision that you made after you have tasked, after you have done all the scenarios, you have come out with, for example, a decision, you have to present it to the management. These are the changes that we need to do. And how are you going to convince them? So using that number, you are not just reading the number, you are translating it, you are interpreting it, and you are going to convince them. Okay? And this is the important one for your career. All right, knowing the difference of each of these software, simulation software, and the function of it. Okay, either you want to go for ABM or DES or SD, or you want to integrate deliberately. So this is related to the decision making. So software is the hammer. You have to know that software is just like a hammer. It's a tool, okay? But the strategy is knowing which wall needs the nail. Means to say that in at your particular wall just next to you, you have the hammer and you have the nail. These are the tools. But what to be solved there? Where should you nail in the wall? All right, so that is it. So I want to test some of your instinct. So this time around is a poll. Okay, I want you to put the answer in the bubble chat. All right, so let us have a look at this. All right, I want an honest answer. It's not a textbook answer. All right, so in your own words right now, what is simulation for? Is it to test a design before building it? Is it to predict the future precisely? Is it to compare options before deciding? Or is it to impress in a final year report? Miss Rati, they have a final year project, am I right?
Yes,
Okay,
yes,
so
we have.
thank you. So I would like to see some answers in the chat box. Which will you prefer? Which will you answer based on this particular poll? Anyone? Probably. like to share your answer based on this poll?
I think to compare option before deciding.
Yeah, you can just pick any answer in here from the screen here, whether it's A, B, C, or D. C to compare. For Miss Rati, what about the rest? You want to write your answer in your chat box instead? Okay. Okay. Thank you, Miss Rati. Thank you, Aldria. Probably the rest, because we have 43 participants, I guess, for this session specifically. It would be great if we can see more answer B, Miss Nabila.
Or it probably all, yeah, Miss.
Okay, so hold that answer, yeah? So I will not give you an answer now. I just want you and everyone to hold your answer in mind, okay? Because I believe by the end of this session, you might have a different answer later on, okay? So let us move to the next one. Thank you. All right, so a moment. Okay. So why I, specifically pick this title. Okay, actually, after upon discussion with Miss Rati and with Miss Nabila, I came up with this title because let me explain the metaphor properly before, because it is the spine, okay, of everything that follows. So think about an architect. What architect normally do? An architect, they do not just begin with AutoCAD. They begin by asking the client what kind of building that you want to do for you. Either you want to build a hospital, either you want to build a warehouse, so the client will definitely provide you the answer. Okay, so based on the answer, then only the architect will build the wall, the floors, the spaces, yeah, using the tools to express the decision. Means to say that whatever that the software that you're using is actually to fulfill the client's requirement. So simulation works exactly the same steps. Okay, you ask the client, okay, you structure it, the model, okay, and then decide. So this three step is very important because it's going to be our base as a checklist for every single case study that I'm going to share with you today. So instead of just assuming, you need to ask. You need to take a big and real world worry into a sharpened and precise question. It's not that, is this warehouse okay? No, it's not something like that. When you go to a warehouse, you don't ask question, is this warehouse okay? You probably need to understand what the problem is and trigger some question. If I add a second packing line, if I add another conveyor, does my average order cycle time drop from 4 hours to 2 hours, for example? Okay, so it needs to be in such a way. Step 2 is structure. You build the architecture, the entities, the flow, the logic for each of the behavior if you're using the ABM. All right, so that is where the software started to be used. This is where the software that you have learned, I remember just now Ms. Rati mentioned on the flex sim, on the power sim, on the analogic, this is where it takes place. Okay, and the final one is the decide. This is where the model run. Okay, you run the model, it produces the output, the simulated futures. And as a person, as a manager, as probably engineer, you will use those simulated futures as evidence, right, between real options with real consequences. Okay, so architect normally does not fall in love with drafting the software. They fall in love with building it, design it, and function which let people do inside it. So same goes to us. We don't fall in love with specific software per se. We fall in love with what is the issue to be tackled with which software and how that particular software able to produce a specific result that can support the decision making. So that is the most important. So we don't come up with a model that does not reflect on the issue or unable to cater the issue in any industry, in any company that they are currently facing, because we are expert in one tools only. No. Okay. So understand what are the issue first. Next one. So you already know, I believe, the DES, the system dynamics, the hybrid thinking. All right. So I will not gonna reteach them. I wanted to recalibrate how you see these things in just 1 minute before we put them together. Okay, so you know that discrete event simulation is foundation of analogic. So I believe the students learn on analogic and flexim works. Okay, so you know the entities, you know the entities like shapes, the orders, passions coming in, the palettes. So they go through queuings, all right? They go through processes over time. Okay, how long does this entity wait? For example, how is the resources utilization rate? So this can be captured under discrete event simulation. The second one would be the system dynamics, which is the foundation of the power sim. Okay, we have also VanSim. We also have others like I think software. All right, so those actually will cater on the model stock flows and feedback loops, right? This is extremely good at answering why question across a much longer period of time or duration. Okay, more on the strategic level, more on the policy level. So it is unlike the discrete event, which is more on the operational level. Okay, this is more on the strategic level. Or you can actually hybrid it both, combining both. So this is the most powerful real world project, okay, related to discrete event simulation and system dynamics. It has been, if you search papers, journals, there are numbers of papers and journals that, hybridizing or integrating these two methods for so long. So for my um, work before this, I have integrate the system dynamics, the data envelopment analysis and system dynamics, okay, in the palm oil industry. So interestingly, there are many other opportunities of doing research as well in other specific industry or sectors, yeah. So keep these three lens in your mind, okay? For every case study I show you next, I want you to start to ask yourself which lens is this, okay? So let us go to the first one. All right, so this is the first stop for us, okay? We go to the C now, okay? Because pot is one of the most I can say purest example of why discrete event simulation exists. Okay, a port is fundamentally a queuing system where the ships arrive, the ships wait, and then the ships serve. I just want to draw the ship kat sini, Miss Ratih. Unfortunately, I'm not a good orang kata apa artis ya untuk lukis di sini gambarnya kapal. Okay, jadi I just mention it here, verbally mention. So you know when ships coming in, they will arrive, they will wait, for the unloading process or the loading process, and then they leave. So every single hour, the ships wait at the port, okay, and the container ships to wait, yeah, at the anchor instead of the berth. It is really a cost for the company, a cost to the shipping line. All right, so the longer they wait, the higher the cost will be, and it also reflects on the port's reputation in terms of their efficiency. Okay, because we have to know that the port reputation for efficiency is brutally competitive regional shipping market. Right. So in Malaysia, we always look at who's our closest competitors, because in port we measure the efficiency based on the TEU. Yeah, I believe many of the students are aware on this, yeah, the TEU, the 20 foot equivalent units. Okay, this is how we measure the efficiency of the port basically. So in this specific study, this is study I did with my student, my undergraduate student, yeah, at one of the port, and we built the model using arena simulation, which definitely mimic the real port operation. And of course, I believe the most challenging part will be in terms of the data collection. Yeah? In a modeling and simulation, among the most difficult part is not just to model it, but in terms of the data being collected. All right. So from time to time, I will share with you what are the challenges, okay, related to this. So we are interested in identify how long do the ships queue, okay, and we measured it again using this TEU concept. Of course, this is one of it. This is standard measure of the container volume, and this is where the architecture of choice comes back. We did not describe the current system and stop there. We didn't do that. We don't just model and tell them this is the current system. We built two alternative scenarios, two different operational structures, ran them using the baseline, and each scenario represented a real decision a port manager could actually implement. And way before that, definitely we need to do the validation and verification process. Yeah, then only we can run it. So what did we find? Of course, there are certain things that need to be improved. Okay, let us go to the next one. So the two strategies that I mentioned just now in that port simulation, it is a clear positive improvement in queuing time because you do not want the ships, the next ships wait too long, yeah, to park at that port. So the queuing time needs to be improved in terms of the container loading and unloading. All right. And I just want to pause a moment in here because the number of itself is almost less important than what made the number possible. Means to say that the port did not need to do it physically. All right. We do not say to the port, you have to stop operation. We want to test this and that. They do not have to purchase a new gantry crane immediately. No. Okay. What we do is actually we explain to them, we present to them, you do not have to physically interrupt the real operation. Okay. What you need to do is just do some changes in the model. Then we simulate it. Okay. So the decision and then tested, proven, and de-risk entirely because we do it in the computer. So these are the things that needs to be clearly explained to the management, right? Because you are not going to interrupt. You cannot go to the heavy traffic and say to the drivers, you have to stop right now. That's not what we're going to do. Same goes to the ship. We cannot say stop. Okay, go to the captain and say stop. No, we cannot do that. Okay, we can only do changes in the computer. So it's a less risk one. So this is the first architectural principle I want you to carry out for this session, where simulation lets organization, find money and time hiding before it spends a single ringgit or single rupiah on this new capacity. We do not simply say that you have to invest this and that. No, we provide several options. Let them make the decision. So that is the architecture of choice. Okay. All right. Next one. This is another interesting story and another interesting research that being conducted also by my undergraduate student. So just want to share with everyone the one that I've shared in here so far and also for the upcoming is the published one. Means to say that it has been published, yeah. So let us move from the container ship just now, or the sea, to the hypermarket. So this is something that we always do. We always go to hypermarket. We always go to the groceries, the retail store, right? So you have experienced this because I have experienced this a lot too. I am standing in the checkout line, very long queue, right? Sometimes, especially during peak hours, peak time. So we started to look at different queue. Okay, the next queue just beside us. Oh, this is quite fast. We opted and moved to the next queue. Unfortunately, the queue started to slow down there. So we always keep, opting here and there. We do not want that. We do not want to experience that. As a customer, definitely.
Okay.
Okay, sorry
as
guys,
a
you can
it's okay.
continue.
As a customer, we do not want to experience that because it's so dissatisfaction, isn't it? Okay, I have experienced that, and I think that is so dissatisfaction. So this study I've conducted with one of my students who also used the same exact concept. We identify what the issues are, and then we use the DES because we know it is more on operational. It's issues related to the queuing. We are not measuring the customers. We are not evaluating the customer's individual behavior. If we are evaluating the individual behavior, we definitely have to use the ABM. But now we're looking at the flow. Yeah, how to improve the flow at a human scale. So we model the existing checkout configuration as our baseline using Arena simulation. This is an option from the Flexim that students are using in there. Okay, and then we built three alternatives, right? Three scenarios. So different combination of open counters and stuff. Sometimes, when we go to the hypermarket, we wonder why the management did not, open another counters. It's a very long queue of stuff, right? But you have to provide evidence. Is it worth for them to open counters, or it's just based on our gut feeling? So simulation, we provide a baseline for that. We provide a quantitative number evidence for that. If you add, for example, in this case, when they add another counter, it's not 2, 3 counters. Okay, can be 1 or 2 counters. The average waiting time cut by 26%, equivalent to 5.24 minutes per customer. Imagine me, Miss Rate, Miss Nabila just now are queuing. So one customer save 5 minutes. Imagine we have many customers a day, right? So the customer's satisfaction will be better and improve, right? So this is where it is important for us to convince the management that not just based on intuition. We are not going to make a decision, especially when involve cost, by your intuition, by your gut feeling. No, we are doing it based on the numbers. We are providing you the quantitative figures. Okay, so again, like what I said, 5 minutes here might seem small for one customer. You have to multiply by hundreds of customers per day who pass through the hypermarket every day, every week, and every year, and multiply that with the customer satisfaction. Okay, because the satisfied customer will always return and they will always spread the word of mouth marketing concept. And you have to understand that every single thing that customers experience, it is actually reflecting on your business. Okay, right? So let us go to the next case. Okay, so we have touched on the port, we touched on the hypermarket. Now on the warehouse again, remember the warehouse that I mentioned of multiple demand coming in due to big sale, right? So this is another study conducted with my undergraduate student as well for the final thesis. All right. So notice the method. Okay, we do not start by opening the arena. We started with interview session with the company staff. Okay, no, sorry, the manager, to properly understand the actual issues. All right, once we identified, we know that we have to use the arena simulation because it related to the flow once again. Okay, so a real picture was clear. So we built the DES model using Arena again because that's the software that we exposed to our student. So the model again mimic, okay, copying exactly what our warehouse manager was worried about. It's about the promotional sales search. Okay, so we started to model it, we verified it, and we ran the what if experiment safely before before the promotional day arrived. Okay, so the simulation revealed that it is not necessarily based on the intuition first pointed, yeah, because at the first time the manager said that I have a bad feeling about tomorrow. I have a I don't have a good expectation for tomorrow's sales. Okay, but then we provide by evidence if there is a surge in terms of the demand and the ordering is increasing. So most probably these are the part that needs to be looked into, because we run the simulation. We show them, okay, each of the process, which point is actually probably will contribute to the issues, will contribute to the problems, will contribute in as the bottleneck in the operation, right? So this is the data that is needed for that particular manager, because they need to, he or she at a particular time needs to convince the board that these are the investment that needs to be done to ensure there will be no bottleneck, especially if they have to hire part-timers, okay, for this specific event, so they have to do that. Okay, so we have touched on the warehouse, we have touched on the port, yeah, we have touched on the hypermarket. I have another poll, so that just wanna see whether each of the participants here stay engaged with me. Yeah? So the big sale day is tomorrow. Where would you add capacity first? So if you are the manager, okay, you have a fixed budget. You can reinforce exactly one stage of the operation today. So where do you put your money? Will you go for the picking capacity? Will you go for the packing? Will you go for the loading door? Or you opted for D? So again, please use the chat bubble to answer or respond to this particular question.
For the other participant, you can type on the chat, on the bubble chat, to see what is your answer. So Mrs. Fazida can, can see what you think of this question.
Exactly. Thank you, Ms. Rati. It's okay. I just want to get feedback. There'll be no marks for this. Don't worry.
For me, I think we cannot tell without the data, because adding capacity means that we have to add some costs, and we have greater cost to add the capacity. So we should know based on the data.
Exactly. Thank you. So I already hear from the lecturer. Maybe we can hear from the students as well. What would be the answer from the student? Anyone? Okay. So we cannot wait long because we only have 1 hour, right? Okay. Thank you, Azrael. See ya. Loading. Okay. So again, when I run this kind of question to my student, we have multiple answer like this, either C or D or probably A or B. But of course, we need data. Yeah, we need data for that. We need to know what are the current operations with the current data. We see how things goes, and we test the what if scenarios. Okay. All right. Thank you for those who are responding to this. Let's go to the next one. This is another part. Emergency department. I believe many of us have go to emergency department due to specific needs. Sometimes we have to accompany our family members, or even you yourself have to go there, okay, because you yourself need some treatment. So I am not sure of how's in Indonesia, but in Malaysia, basically, it's different when we go to ED in private hospital compared to the government hospital. Of course, because of the number of patients, the number of patients in the government hospital is quite huge, especially during certain seasons, right? So we need to look at how things can be improved. Right. So this is another study that this is postgraduate studies. Yeah, we we have, it's very challenging to share with everyone when we want to conduct this study at emergency department. We have to go through multiple layers of approval. Okay, collecting data, you have to know it's different from collecting data from for hypermarket, for the other one is warehouse. It's different because it doesn't involve lives. It involves boxes, merchandises. But in ED, it involves humans' life. All right. So we work through several requirements and approval from the hospital up to the higher level. And then because there is no recorded data, so my students mostly have to repeatedly go to emergency department to make a time study, collect the data, right? And that happens only after we have interviewed, right? The staffs and also the head of department over there to understand what are the issues, what are the problems, and what kind of tools again that needs to be used. Because we need to understand if they want to do, if their issues is related to the flows. Flows means to say that the operational flows, definitely it will be using the discrete event simulation. So in this case, again, we use the DES, all right? And we have to understand because none of us actually comes from the medical background. Okay, so we have to understand the process and the terms as well. So upon registration, and then they go for triage and then consultation, treatment, either they will be an admission or they will be discharged. So we have to understand those. So that's the first thing. Yeah, we have to map the real procedure in the emergency department, and then we evaluated it. We model the resource utilization. We have to understand the numbers of the doctors, the nurses, the beds. We have to understand. We cannot simply suggest to add doctors, definitely, right? Or we suggest the management buy more beds because the patients are now waiting out there. No, we need to provide evidence in this case. If not many customers being, treated in a specific time of period, what will be happen to the, numbers of queuing there? So only once we understand the structural, then we begin testing how the department might redesign to handle the patient flow better. So here is where this case matters most. Yeah, we identify and then we evaluate, and then in this case, if the cost will be the money, okay, the financial, the pot, any delayed in the shipment, we provide unhappy shipping line. However, in emergency department, you have to know that the cost of unexamined bottleneck is someone's life. Okay, is related to the patient waiting and struggling in the room while they are being examined, and if the patients being treated quite late, it will worsen the situation. And so this is why simulation, in my view, one of the most ethically important tools an industrial engineer can master, because healthcare administrator, they cannot experiment the real staffing. They cannot simply say that we have to add more doctors, we have to add more nurses, we have to add more beds, we have to do some construction here by adding more room. No, you cannot simply change like that. Okay, it is far too risky. So the simulation give an option for the management to see what if we added this, what if we change this. So those things are important without interrupting the real process, without interrupting or probably contributing the minor injuries. So we get a better answer without any single real patient being experimented, okay, because we never touch them. We touch only the model in the computer. Okay, so before we go further, I want to be honest with you about the limitation, because the best engineers I know are the one who understand the boundaries of their own tools. Yeah, so you have to know that DES, they have certain limitation. That's why when it involves a more strategic ones, okay, more longer duration, we started to focus on the other tools. All right. So I have explained to you and share with you related to the more operational, like DES, patient flow in ED, the warehouse, the pod. But this is the essence, the microscope. I can say zoom in. Yeah, it zooms into hours. It zooms into days. It tells you with tremendous precision what happens in a queue, what is current condition. But DES do not naturally explain why the system arrived at the structure in the first place. Okay, we understand the flow, but we don't understand why from the very beginning. Why does this hospital, for example, run short staff during certain months? So this needs or can be tested using another method, which is system dynamics. Right. So I believe they have learned uh, power sim, right? For this. So
Some
I was
some
the
student has
oh,
some
some students
student
has.
have learned, yeah, but not all the student miss because it's in undergraduate mostly.
Mm-hmm.
But
Mm-hmm.
this the system dynamic we learn on the graduate, yeah, on the graduate
Level.
program,
Ah,
yeah.
okay.
So only
All
some
right, thank
students
you.
that use system dynamics as a final project.
Okay, interesting. So if you have the opportunity to learn it, explore it, okay, because it's a very, very good one for your future and adding it to your resume, inshallah. All right. So it's not just these two tools. There are many other tools and software that you can learn, especially during the semester break. Take the opportunity to learn that, and you can approach a company. You can add in your resume later on once you have used it in your project, so on and so forth. Yeah. So this study, another one. Okay. Remember the whole world actually were hit by COVID-19. Okay, so this study, what we did, this is co-authored with my colleague and our research team. We asked a national scale question: how did the many different intervention strategy in the Malaysian government specifically implemented during COVID-19? Actually, we want to look at the interaction between each of the variables. Yeah. So what we did was we built a causal loop diagram. The essence of the system dynamics. Probably the undergraduate student unable to really see on this, but I'll just share. Yeah. So hopefully after this you are able to connect. If someone mentioned about the system dynamics, so system dynamics, the ability is to capture the interconnection between each of the parameters, each of the variables. Yeah. After this, I'll show you the CLD. So um, here's the insight that I think every future policymaker. So normally for system dynamics is for more on the strategic level, more on the policy making. The managers and engineers in this room needs to internalize. Yeah? Some strategies they delivered quick win in the short term. They produce negative unintended consequences that only appeared later. So in this case, yeah, a lockdown might flatten the infection curve quickly, but the same lockdown sustained too long, strain livelihoods and public compliance. After this, I'll show you how's the interaction. Okay, so if you just listen like this, it's going to be hard for you to imagine. All right, so the feedback loop, okay, once you have the CLD, you will model it later on, okay, using the PowerSim, or in our case, we're using the iThink software and FanSim as well. Okay, and we will see the result, because normally for this case, we don't go to operational, we go to more higher strategic level, much more longer duration for that. Yeah. Okay, so this is the example. Okay, this is the paper. So basically, all the paper, all the sharing that I've just made from the very beginning just now, it all been published, like what I mentioned. So this is the paper that used the system dynamics, okay, and system thinking. This is the CLD. All right. So you can see, when in the DES, we know the starting point, right? So we know the entity arrival, that's the starting point. But in causal loop diagram, it's hard to identify which is the starting point. We know that at the end of the day, this is the part of it, right? It connected with the arrows. Okay, so you actually may see each of these are all connected. You can see all the arrows here. All right. So it's not just on the spreading of the viruses at a particular time. We don't only just see that, okay, based on the lockdown movement, but we also look at the other side of it. Here, we talk about how fatigued human is. So what will they do normally? So some of them probably will just ignore, okay, the movement, and they bring more to the spreading cases. So these are the things that we look into as well. Okay, so the falling movement, sustained over weeks, of course, is going to be good, but the public normally will in turn feel fatigue and push the cases rise again. So you can see that the cycle in here, right? So this is the cycle here. Okay, so there are many actually cycles for system dynamics. You can even do it by sector, do it by a specific section, so on and so forth. Okay? So this look at this. Okay, there is no starting point, but we know that at the end of the day, this will be the main focus in here. You cannot ask which node caused the others. They cause each other continuously in a cycle. These are all the cycle here. So for undergraduate student, because you're probably never exposed to this, so this is a very, very good one. If you want to provide, your final thesis later on from the strategic level. Okay. As a student, you can always explore. Okay, there is no such thing of mistakes calling as a mistake. It's the time for you to explore. Okay, and always seek advice from your supervisor or your lecturer. Uh, okay. And then let us move forward just a bit more, yeah. Related to pharmaceutical, this is another good studies made by my postgraduate studies, PhD studies related to this, approaching pharmaceutical warehouse, okay, where lean simulation, he basically integrated two things, VSM and also DES, all right, and come up with the, I can say, uh, quantitative evidence to the management of this pharmaceutical. Another challenge that we face at this particular time, I still remember my student back and forth, have to convince the management of that pharmaceutical company, and then until the level of we have to go sign the NDA, the non-disclosure agreement, which means that we cannot expose certain information. For example, in this case, we cannot expose the name of the company and all. And of course, the data being collected for several months, not just to understand the process, but also to understand the entire things in that particular warehouse and what kind of data needed, right? So this is another thing that you can also consider later on. Okay, interesting one. So I have another poll basically, but I guess uh, we probably 5 minutes remaining. Yeah, this is right, Miss Rati. Yeah. So just probably
Yeah.
skip this one.
But I
Mhm.
think you can, if you have still much that you have to say it, so we can just ended up the lecture maximum and at 10:30, so you can
Okay.
continue, Mrs.
All right.
But
Thank you. Okay.
yeah, but there's still question here, so yeah, you can continue first, and then we go to the question and answer section.
Okay, thank you. Thank you for that. So this is one question. It's okay for you if you don't want to answer at the moment, but something that can trigger you. So your final year project is a real factory with chronic late deliveries. So what is your move? Whether you want to go for pure DAS, or whether you want to go for pure SD, whether you hybrid it. Okay, so whatever your answer is, it must reflect what are the problem faced for that particular real factory. Okay, so what is the problem? Then you know which method is suitable to be used. Okay, right, next one. Okay, let us pull all the case study that I have shared with you. okay, the actual architecture of choice, because I want you to leave this specific session with something you can apply, not just listening or probably admire with it. Now, you need to frame it. Every project that I have shared with you, that we have discussed today, begin with someone turning a very vague worry into a precise, okay, testable question. Not the question like, or the statement like, the pot feels so slow. Okay, but will resequencing birth allocation reduce queuing time below specific hours? So that question needs to be asked. Okay, that's the first one, the frame one. The second is choose the lens. This is the step most undergraduate training skips, because most courses teach you one tool per semester. So you thought that that particular tool is suitable for every problems to be solved. No. Okay. So today you have seen the DES function. Okay, the port, the hypermarket, the warehouse, the ED, the pharmaceutical ones just now, the COVID-19 issue. So you have seen the system dynamic function as a telescope, the COVID-19 causal loop diagram, the SCLD just now, okay, the pharmaceutical where you combine VSM and DES using analogic basically for that one, okay. And the step 3, you build and test it only. Now the software, here only the software, either you opted for any logic or your FlexSim or your PowerSim actually opened. This is where, okay? And because this is where again, this is the question being asked, okay? This is where you identify whether it is DES or SD, whether it is DES or SD scope. This is where the software, the analogy, the FlexSim, the PowerSim, Arena is being used. And this is the section 4, where you decide and you defend, because the simulation does not make decision for organization. It gives the decision maker the evidence to strong enough to defend a choice in front of, again, the management, the hospital board, the entire government policy committee. So every single case study you have seen in the last, I can say 40 minutes, actually follows these 4 steps, right? So the only things that change the case to case is which lens, up to this one, yeah, which lens fits the problem. So the case identified, choose the right lens. Okay, then only you can choose the right software in building it. And then the result will help you in terms of deciding and defend. Even though you have all these things, okay, but I want you to know that there are limitations and there are ethical considerations. You have to know that your model is depending on what you actually key in. Okay, if you key in a wrong data, wrong input, and it will come up with the wrong output. Okay, so models can never fully capture real world complexity. They can never be 100%. It's very, very impossible of replicating 100%, because the real operation might be much more complex. All right, and you also probably will be over reliance on output. Okay, and you might think that the high computational cost for fine-grained models, that you have to remember that whatever software that you're using is a one-time investment normally. Okay. The ethical consideration, you have to look at who will benefit the strategy, who bear the risk. All right, that's the most important part. There's a risk, okay, related to this. Algorithm bias is actually a real concern. Okay, and then the transparency, can the model be explained to stakeholders? Can you, once you have developed the model, you understand everything, can you explain it? It's not just building the model. Okay, this is another tough thing, Ms. Rati and the rest of the audience, especially when the student present it in their final year project. Okay, so sometimes we invited the industry people as well, apart from the lecturers. So they need to defend their work, they need to defend their project. So this is the hardest part, because they know the model, but it's hard for them to translate it Okay, it's hard for them to explain who actually benefit from it. How are you going to convince it to the management? Okay, the next one would be under accountability. If a model-driven decision cause harms, who is responsible for that? Okay, so as a modeler, a simulator, for example, who is in the research itself, or as a consultant, you need to know exactly whatever changes, whatever scenario tested that you made is actually based on the logic side. Because at the end of the day, you need to convince them. Okay, there is no such thing of providing scenarios which doesn't benefit your stakeholders. No. Okay, so these are the things that you have to look into, the ethical consideration as well. And so this is your probably in your study, before your next analogy or flat sim assignment, so you need to write the strategic question on paper first before opening the software. You need to understand what the question first. You just cannot simply jump into analogy. I want to use flat sim for this specific project. No, you have to understand what the question is, what to be solved. Okay. The second one is your final year project. It has to ask the lens. Okay. Whether you want to opt for DS, ST, or ABM. Okay. And your future career. Okay. Be the engineer who bring evidence. Okay. You cannot be an engineer based on your intuition decision. Okay. You need statistical evidence, you need figures, you need numbers, because these are the things that needs to be convinced, needs to convince the board, the management. This will be the effect if we opted for scenario A, if once we experiment it, or we have several configuration we have done. So these are the output, these are the effect, these are the impact, not only to the numbers, not only in terms of percentage, but definitely for a business, they want to look at how much it will help in terms of the cost. Okay, how much profit will they earn, example. So I want you to be, especially the students here, okay, to be the engineer who walks into a room full of confident opinions, means to say that you put the evidence on the table. Right? You have skill, you have the software probably, but if you are unable to deliver it, to convince them, then it will break you. Okay, so it's not just a good report, a good presentation is also needed, a good communication skill is also needed to convince them. Okay, and you have to remember the software that you're using during your undergraduate probably will be updated every few years. Okay, so you need to always get into the latest software version so that you know that you are keep in pace with the latest one. Okay, next one. Okay, remember the first question, the first poll. Okay, related to, I believe that, let me go through. This is the first poll. Yeah, what is simulation for? So again, I hope by end of this session, okay, you start to understand that the simulation it's not the software you operate. It's the architecture you design based on the real question by choosing the right lens, okay? Means to say that the right method, okay? And then you build a safe experiment. You do not risk the real world operation. You do not interrupt the real operation. You do not say to the doctor, stop treating patient now, I want to do some testing. You will not do that. You are dealing with the right method and right software. Okay, so you have to remember every single part, every checkout lane, every warehouse, every hospital bed, every nation that is struggling and wrestling with the pandemic, every shelf, okay, at the warehouse, every one of those in the building, you have to know that they are facing certain issues that need to be cater using specific tools and specific software. Okay, if before today you know how to operate the drafting software, I hope today you start to learn of how to read, okay, how to design the blueprint of that particular problem itself. So I guess that is all for this specific session from me related to the sharing. Terima kasih. Thank you very much for your attention, and thank you for responding. Those who responding to the from the pool, yeah, itself. All right. So pass back to Miss Rati then. Thank you.
Okay. Yeah. Thank you, Mrs. Fazida, for the sharing session, or maybe it's lecture for us, yeah. It's interesting sharing and lecture because for me, I also working. I also have work on my final thesis on the system dynamics
Mhm.
for the supply chain disruption and resilience. So I
Mhm.
really relate so much on your sharing session. And then we will go to the question and answer session. For the participant, you can drop your question on the comment section, or you can raise your hand if you want to direct uh, asking or direct question to Mrs. Fazida. And you can also use bahasa. Partisipan atau teman-teman di sini juga mungkin terutama untuk mahasiswa ya bisa juga bertanya menggunakan bahasa Indonesia. Kebetulan Mrs. Fazida juga dari Malaysia ya, so it similar with bahasa.
Wah,
Jadi boleh
boleh.
pakai ya, jadi boleh pakai bahasa Indonesia juga teman-teman ya. For the lecture, because it is international guest lecture, so we use English. But for the question and answer section, if you want to question, if you want to give question in bahasa, you can drop the question. Yeah. Okay, we can see for the chat there are two questions. The first one
Mhm.
is from Mr. Miftahul Arifin. Actually, Mr. Miftahul Arifin is a lecturer from our study program also,
Okay.
Mrs. But he's now working on the doctoral research.
Mhm.
Yeah, he's taking the doctoral degree. So the
Mhm.
question is about he is currently working on doctoral research, which involves simulation for technology adoption in the electricity sector. I have a practical question regarding software selection. There are many simulation platforms available, such as NetLogo, AnyLogic, FanSim, PowerSim, and Python-based frameworks. For researchers whose objective is strategic decision support rather than operational optimization, what considerations should guide the choice of simulation software? In the other words, how do we know that a particular software platform is the right one for the problem we are trying to address? So the question is about the softwares. It's about
Mhm.
the software used on the simulation.
Mhm. All right.
You will answer directly, or we just collect the question first?
I can answer directly for this one.
Okay.
Before we go to the next question. Okay. Thank you for the question, Miss Tahul Arifin. All right. So this is interesting one, and many of the students also asking the similar question. Basically, what kind of tools? I mean, like you already identified the tool, but what about the software itself? So you have to know, yeah. This software basically they produce the more or less similar things. Yeah, they offer more or less similar things, basically. All right, but of course there are always the strength of specific software. So for me, I always told my student, okay, so yeah, in terms of the system dynamic itself, the available software related to PowerSim, VanSim, we have in here we have I think before, yeah. So I cannot simply say that for a specific problem like this, you have to opt for this is the I think only. No, okay, as for me, I believe that each of the simulation software depends on the usability of it itself. right? Some provide you with, I can say, much simpler version and user friendly. Some probably might need some algorithm extra. So it depends on, again, once you identify the lens and all, again, how familiar you are with that specific software. That's the most important. Okay, so the software that you are familiar with and able to provide and produce the result that is needed for you to achieve your objective of study, that will be good enough. Okay, rather than keep testing, okay, the many types of simulation software, because it's going to, at the end of the day, you're going to waste your time, right? Because at the end of the day, basically advanced sim and power sim, and also I think, okay, the Stella, I think nearly the same. Of course, like what I said, they have their own strength here and there, a little bit here and there. For example, the power sim, they have a different features that is much more advanced. And now for this Stella, I think it's actually among the first um, software that's being introduced. Okay, from if you from system dynamic, you are so familiar with Forester, right? Stone and all, right? So you know that among all will be they use the I think software. Okay, I really hope that I can answer you that, because it's hard to specifically say, Ms. Ratih, you need to use this benzene only. No,
Oh,
okay, it's not
okay.
going to be like that, right?
Okay.
It doesn't work like that.
Okay, so it depends on the what we usually use or what we master on the software, and then can it answer our question or not? Yeah,
Exactly.
yes, yeah.
The most
For
important
me,
is, can it answer your the objective of the question? Can you
okay,
it help to achieve this objective?
okay.
All right.
Okay, thank you, Mr. Arifin for the question and Mrs. Fazida for the answer. So we will go to the next question. Good afternoon, Dr. Fazida. My name is Dinda Natasha. Uh, she is a logistic engineering student. I have a question regarding your slide on the feedback loops. In the Malaysian COVID-19 case, system thinking was used to evaluate government intervention. Do you use similar potential for supply chain or disaster logistic problem? And which feedback loops would be most critical to capture that context? Okay.
Okay. All right. Thank you. Thank you. Good afternoon, Dinda. It's already afternoon there. It's not afternoon yet in here, Malaysia.
I think it's morning.
Okay, never mind.
It's still
Just
morning.
kidding. Okay. It's okay. Okay. Good morning, Dinda. Thank you for the question again. It's a different situation. It's a different issues being brought up in here. So, both are disaster, we can say, but it's not logistics problem and supply chain. You need to understand what are the issues first. It's different from the COVID-19 just now. COVID-19 is more for my paper is actually focusing on the government intervention. Yeah, for the logistics problem, for the logistics and also the supply chain, we have to understand what the problem is. Was it related to um, the strategy of probably expanding the berth, okay, the port size itself, okay, or is it related to um, impact of the COVID-19 to the logistics? So if so, the CLD itself will be different. Okay, you cannot simply take that CLD of COVID-19 and assuming the same exact can be used for other issues as well, because the variables, the parameters will be different. Okay. Do I answer you, Dinda?
Oke, Dinda, bagaimana Dinda? uh, you can use you can, sorry, Dinda, and for all the students, you can read the transcription ya on the bottom. If you cannot follow the English directly, so you can use the transcription. Okay, I think it's answer the question, yeah, Miss. It's based on
Thank
the
you.
problem, yeah, the variable, and for the questions. Before moving into the next question, I think we'll go to the Mrs. Yulinda first. Mrs. Yulinda also our uh, lecturer in logistic engineering program.
Okay.
Okay, thank you. Good afternoon, Mrs. Fazida. Thank you for your presentation. It's so insightful and engaging. And my name is Yulinda. I'm one of lecturer in logistic engineering department.
Mhm.
Currently, I'm work in optimization field. So I have a question regarding simulation and optimization. As we know, simulation is powerful tool for representing a real world system, and we can understanding how they behave, something like that. But simulation usually just evaluate different scenarios, then directly finding the optimal solution.
Mhm.
In Mrs. Fazida opinion, how can researchers, maybe student, overcome this limitation? Or can we combine optimization model and simulation model together to get a powerful method, something like that? Thank you. Or maybe
Okay.
this, or maybe my question can trigger other students to think more about simulation and modeling. Thank you, Mrs. Fazida.
Mhm. All right. Okay. Thank you. Thank you so much, Miss Yolinda. Okay, thank you for the question. Yeah, basically, quite numbers of students also, I can say, started to ask the similar question of hybridizing or integrating between these two methods, right? So it is, I can say that it is not something impossible to be done. Because of course, like what you said just now, there are some limitation in terms of simulation. Of course, you want to look at the optimization as well. So it can be done, but you need to have a proper references for that, especially when you are a researcher, right? You want to produce a paper, you want to produce your thesis, to defend your thesis. Of course, the next question will be, um, if you combine or hybrid or integrate these two methods, okay, how's the integration looks like? Will the input from the optimization, for example, be used for the simulation to be tested, or it will be a hybridizing in terms of replacing between these two methods. Either you opted for optimization or proved by for example, simulation itself, okay, which produce better, for example, yeah. So it again, like what I have said, it is actually complement between these two, I can say, yeah, because the simulation will answer what happened if we implement this decision, right? The optimization would definitely ask what decision or which decision should we evaluate to achieve the objective. So these two perform a very powerful methodology, okay, for that particular situation. Okay, Miss Linda, I hope I answer you.
Okay, thank you so much for your answer, Miss Fazida.
Okay.
Okay, thank you, Miss Yulinda and Mrs. Fazida.
Mhm.
We will go to the next question from Zafira. Hello, I am Zafira from Telkom University Purwokerto. I have a question about the case study number 2. Which of the three scenarios achieve the 26% faster checkout time shown on the slide? And what were the main challenges during the actual implementation? Thank you. It's
Okay,
the
thank
multiple
you.
case,
Thank you, Ms.
supermarket study
Zafira.
cases, yeah, I think.
Yeah, refers to the case, if I'm not mistaken, this is the case of checkout at the hypermarket. Okay, we have three different scenarios. As the students actually, each and every one of you also can read the case, the paper that has been published, okay, for this specific case. All right, you can look at the abstract, which highlighted the scenarios, okay, and which scenario is actually reflecting on this 26%. However, when the second question is actually what were the main challenges, right? It is actually the challenge begins not just by producing the result in terms of the implementation. The challenge is way before that. Okay, upon our data collection, upon the modeling, so multiple numbers of data collection needed, especially during the peak time, holiday seasons, during a normal and ordinary time. And then in terms of implementation, if you can recall from the very beginning, before I share my slide just now, I always told my student that we are not a consultant, right? We are a researcher. We produce the result. We let the management to test it if they want to test based on the result that we have showed to them. Okay, so in this case, it is actually quite tough, because it involved in terms of the number of resources, the counters to be open. Okay, assuming that the number of the customers coming in, multiple numbers of customers coming in, so they need to open another counter, right? So it is, even though we have provide evidence for this specific hypermarket, you need to add this one more counter. But again, it involves cost. That is the most difficult part. It involves cost because you need to hire more workers. Okay, so we need to also convince them that by adding this one cost, for example, adding this one cash checkout counter, you can increase. The most important is the customer satisfaction. Okay, however, of course, there's always a cost in this, but you have to remember that when customers satisfied, they will always return to your hypermarket. That will contribute to more profit. Okay, that is the most challenging part, to convince them in terms of implementation, especially when you test by a scenario that require them to inject some investment. Okay, all right.
Okay, thank you, Mrs. Fazida, for the answer. I think because we are now working on the discrete event simulation course, so there are many questions from our students. As I said before, that our students is kind of difficult to develop the scenario. So it represent from the Zafira question about the scenario of the simulation. And then the last one is from Muhammad Azril. I have some question about the COVID-19 incident yesterday. As I know, many companies face temporary interruption in the distribution of raw material and warehouse inventories due to the lockdowns. So I think forecasting models could be failed to accurately because of the unpredicted condition. Is simulation better to have decision makers respond to such uncertainties? Or do you believe that the COVID-19 logistic crisis accelerated the adoption of simulation and digital twin technologies in supply chain management? I think the answer is it a better use forecasting or simulation to represent the real condition of the impact of the COVID-19
Yeah.
of the
Okay.
COVID-19, Miss.
Yeah, thank you. I think this is also a good question. Okay, because traditional forecasting model normally requires, of course, patterns from historical data, right? They requires if reflects to the due to COVID-19 reflects to the logistics movement and all. It requires data like demand, lead time, seasonality, trends, so on and so forth. But of course, in this case, COVID-19, when it hit the entire world, is something totally new, right? We don't have any base data for that. Right? But we can deal with simulated data, right? Like what I have mentioned also earlier, simulation is a simulation tool. You play with the process that you can change, for example. Okay, same goes to system dynamics. We have a causal loop diagram. Okay, effect from one parameter to another parameter. We can use a simulated data. And I also mentioned that there is I cannot say no, but it's very impossible to have a very accurate data that represent the real world. So that is the huge challenge there. Okay, and in this case, what I can say, yes, there is actually a broad agreement between industry and academic literature related to COVID-19 significantly affect or interest accelerated to the simulation digital twin. And interestingly, a moment, I have no idea why it turns out to be small on my screen now. A moment, yeah. A moment. Okay, sorry. So Muhammad Azril, I guess he is quite familiar with the digital twin technology. Is it? Yeah, because digital twin also is physical, I can say, simulation tools that can be used, yeah, presents. And one of my PhD students is now using this digital twin technology as part of their studies, yeah. And interestingly, yeah, I believe it can be accelerated in the adoption of simulation and digital twin technology because somehow, if I'm not mistaken, if this question being reread, okay, the COVID-19 logistics crisis means to say that how COVID-19 actually affect the logistics activities, right? So it is possible, but again, if you want to study in terms of the system, then in terms of the digital twin technology itself, the effectiveness, the adoption rate, and all, digital twin itself is a high cost. Not many actually would invent on that. So it's going to be a very challenging one, okay, in terms of the management to invent in the digital twin, and it's going to be a tough one. But it is possible. Yeah, it is possible to be done. Looking at what objective you want to achieve. Again, it goes back to the objective. It goes back to the lens itself. Remember, after you ask question, you understand the lens. Okay, any
Okay,
more? Mm-hmm.
okay. Thank you, Mrs. Fazida. I think for the COVID-19 pandemic, it. Oh yeah, okay. Thank you, Mrs. Fazida.
Thank you.
There's a chat
Welcome.
from Azril. Okay. I think it's interesting. For me, I choose the simulation. I choose the system dynamics also because I work. I work on my thesis on the COVID-19, so I choose the system dynamics because we don't have the historical data, but we can simulate the pandemic or the disruption based on the structural modeling. So,
Yeah.
I use the system dynamics. So for Azril, maybe if you interested on the resilience or the disruption, supply chain disruption, you can uh, go into the simulation, especially the dynamic simulation, because the disruption will be captured on the dynamic simulation, I think. Because Azril is the second year student, Mrs. So he will enter the third year student the next semester. So he has to think about what the final project that he will choose, yeah, to present the bachelor degree program.
That's really
Oke,
good. That's really
maybe
good.
iya. Silakan ada yang mau bertanya lagi untuk partisipan bisa menggunakan bahasa Indonesia aja ya. Nggak masalah kalau mungkin agak kurang familiar atau mungkin apa ya takut-takut nanya pakai bahasa Inggris, boleh pakai bahasa Indonesia teman-teman. Silakan. Sambil menunggu mungkin there is one question from me, Mrs. Fazida. Based on my experience and my working on the system dynamics use power sim, I have difficulties to enter or to inject the uncertainty of anything, yeah, of demand, of price on the system dynamics. So on the power sim. So what can we do to inject the uncertainties of the demand or on the price uh, Can we just inject the historical data, or we need some syntax, or we need some we need some syntax or the equation to inject the uncertainties of the demand or uncertainties of the price.
Okay, interesting. So you are now at the stage of building the model, or the model has been built and has passed the verification and validation process?
The model has been built on the SFD, and then it also has simulated the best scenarios, but I want to develop the model to
Uncertainties, yeah.
inject the uncertainties.
So your uncertainties basically, sensitivity analysis will systematically varies, uncertainty parameters, because I would rather suggest you to look at the range of the uncertainties in terms of the percentage and all, because if there is no data, of course it's going to be a challenging one, right? But look at for example, the demand itself. What would be the it's just a suggestion. Look at the normal range of uncertainties, because there are certain risks, certain that can be part of your base. Yeah, because there is no previous data. Definitely, it's going to be a challenging one for each and every one, because there is no data. But for every decision that you put in your model, and how you justify it in terms of academically define it or justify it is needed. Means to say that how do you come up with that specific range, for example? Okay, just share with everyone. I have before this evaluate this one thesis, not one, I mean multiple thesis. Okay, but when they come up with a specific range of things that or data that need to be tested, in this case, for example, uncertainty, there's always a question of how do you make a decision on that? What are the bases that you come up with that one? Okay, if you opted for 10%, 2%, 20%, for example, where it's not just based on your intuition, isn't it? It's based on a basis, not specifically COVID-19, for example, because COVID-19 is just something that hit the rest of the world without we never expected it. Same goes to what happened now when Iran closed the Hormuz, right? So it's something unusual, but there is a possibility you look at the range of the uncertainty. There must be a basis for that. Okay, all right.
Okay, thank you, Mrs.
Welcome.
Fazida, for the answer. I will try to use it and inject it on my model soon if it's already done. Because the development model, because I have done it, I have done the develop model, but the base model I have a build it. Okay,
So you can test it using sensitivity analysis as well, right?
yeah.
Mm.
Actually, I have done the extreme condition, not the
Oh,
sensitivity
okay. The extreme
analysis.
condition test.
Yeah.
Okay, good one.
Okay, thank you, Mrs. Fazida. And then, okay, I will remind for the participant to fill the attendance form on the comment section. You can scroll the comment section to find the attendance form to get the certification. To get the certificate, I mean. Okay, thank you for Mrs. Fadida for the lecture and also for the discussion section that answered many questions for us. And we will end this session by choosing the best questioners of the session. Maybe to Mrs. Fazida, you can use the best two question for you. You can choose from the questions before and choose the best two questions up to you or up to your thoughts and your interested question. You can you can choose two questions, two best questions from the questions before.
It's going to be a tough one for
choose
me because all
student,
questions
Miss Fazida,
are
not from
good.
the lecturer. Please choose the student. Then choose
Yeah.
as a lecturer. Thank you.
So it's actually every question. I embrace all question. No question is good. I mean, should means to say that the students show their interest in this. It's hard for me, Miss Rati, to choose the best question. It is so hard. But I guess I please the rest of you jangan terasa di hati ya. Sekiranya saya memilih sebahagian saja untuk itu best
Okay.
question, is it?
Yeah, it's the
Bimbang
best
ada yang
question, Miss.
tergores di hati ya. So I believe that as of now, probably I choose Muhammad Azril's question. Is it a student? Is
Okay.
it a lecturer or
Yeah,
student,
it's
right?
yeah, Muhammad Azril is a
Not a
student.
lecturer question. Okay, and also uh, probably Dinda, I guess.
Okay,
Okay.
okay.
Yeah,
Miss
because
Azril
these
and
two
Dinda.
questions it triggers um, me specifically on how students see, yeah, the method itself and the software itself, yeah, and how things work. Yeah.
Okay. Okay, thank you, Mrs. Fazida. So congratulations to Muhammad Azril and Dinda Natasha for the best question that choose by Mrs. Fazida. Okay, for the person, it will be sent by the program study, yeah, Mrs. Yulinda, for Azril and for Dinda. Okay, thank you, Mrs. Fazida, for the lecturer and the discussion on the question and answer section. I will summarize the sharing session. The first one is that we have to look at the question of the research or of the what we are working, and then we can use the perspective of microscopic of or telescopic, and then choose the right software to answer the question. And also we should focusing on the problem, not on the software. And then there are many case studies that we can learn from your presentation. And also we can integrate simulation method, especially in discrete and continuous, and also for the other method, we can integrate or hybrid the simulation and the other method. And
Yep.
also, I think this is the most important, Miss. The step on the simulation and the architecture of the simulation is started with frame the problem precisely with the precise data and the exact data, and then choose the lens, microscopic or telescopic, and then build and test the scenario and the model run. Because some software creates the different result on the running software. So I told the student, if you use the different software, you can use replicate running to make sure that your result is optimum, I think, or it's the best result. And then decide and define the choice, what and then decide and define the choices that you have simulated on the scenario, and then give it to the board or the management as the decision that they will use to decide. And then the important thing is the limitation and the ethical consideration of the simulation, because in the simulation we can inject the assumption, we can inject uh, the border of the system. So we have to look at the ethical consideration
Exactly.
to make sure that the model and the simulation represent the real system.
Mm-hmm.
Okay.
Thank you
I
for the
think
summarization. I just want to add one
yes.
thing. Yeah, related to the replication you mentioned. Yeah, even at the PhD level, sometimes the reporting, they will ask you how many times you replicate.
Yeah.
Yeah, that is the most
Because
important part. Yeah,
because we use randomize at the simulation, yeah, Miss. So we have to use replication running.
exactly, exactly. All right, thank
Okay.
you.
Okay, thank you for the participant, for the Mrs. Fazida, and for the lecturer that participant at this guest lecture. And then I think thank you so much for the participant. We will send you the certificate for the participant later after this meeting. And then for Mrs. Fazida, maybe I will remind you that there is some document that you have to uh, assign, yeah,
Okay.
regarding the partnership, yeah, at our university. Okay, thank you everyone
Thank you everyone.
for this
I really
session.
hope that this session benefits you guys. See you insyaAllah in
Yeah,
future. Jumpa lagi. Terima
okay.
kasih.
See you
Assalamualaikum.
all. Thank you. Assalamualaikum
Thank you.
warahmatullahi wabarakatuh. Thank you, Mrs. Fazida.
Okay.
Bye-bye. See you next time.